Hello everyone, welcome to the next video of Quantum Mechanics is Wrong and Anyone Can See Exactly Why. Should be part 3. Last time they explained to us how apparently a photon needs to be 1 second long because the definition of hertz is per second, so anything below a second isn't possible, which is one of the more wild misunderstandings I've ever heard in physics, but let's go on, I guess.
Mainstream science generally tells us that Einstein's explanation of the photoelectric effect proves the particle nature of light, or the photon.
First of all, it wouldn't prove it because nothing is proven in science. It's, evidence is collected. Sometimes you could say it's confirmed, which is not an ideal choice of words because confirm could lead you to think it is proven, and of course nothing can ever be proven in science. Now, with that said, I don't necessarily think that you need to have the I do apologize, that you necessarily have to invoke the particle explanation. You can probably get away with the wave. I do apologize. I do not know why. Usually people aren't texting me, but obviously right now they are. Yeah, so let's keep on going.
This is not a correct statement, and I go into much greater detail in this video called The Quantum Flaw. And around the 3146 time frame in that video, I specifically start talking about the photoelectric effect. Here is a real quick summary. We just learned about the problem with this photon energy equation, in that it is a 1 second wave equation.
It still isn't.
When certain frequencies of light are shined onto metal, then electrons are ejected from that metal. That's the photoelectric effect.
That's extremely simplified. That and just categorically not true. When the frequency that the photons are coming in with is high enough so that the energy of the photon is higher than the binding energy of one or multiple of the electrons, either high enough to put it in a higher orbital, or like in a higher sphere, or high enough to knock it out from the atom completely. That's the distinction between the inner and the outer photoelectric effect. Then yes, then the photoelectric effect happens.
The problem is that the photoelectric effect happens right away without delay.
That is correct.
And in order for the photon energy to be created, it takes 1 second worth of time.
It doesn't. It doesn't. No. It does not do that. Oh God.
Because it's based upon this frequency term. That's a huge contradiction.
If you don't understand the topic, yeah, I'm sure I can understand how it looks like a contradiction to you. Jesus.
This is Albert Einstein's 1905 photoelectric paper. In this third paragraph, this is where he starts to talk about wave-particle duality. He says the wave theory of light has proved itself splendidly and will probably never be replaced by another theory. But that wave theory may lead to contradictions when applied to the phenomena of production and transformation of light. This is where the particle nature, or photon of light, comes into play.
To be quite real with you, I don't fully understand what Einstein's talking about here with the production and transformation of light. Especially the transformation part, I find a bit peculiar. Why should it be a problem? Like, immediately out of my understanding of this sentence, I would not come to a conclusion of why he would write it. Then again, he did write that in 1905, so I mean, that was almost 120 years ago now, so cut him some slack, maybe.
So then the simple question would be, if light is produced in discrete chunks, then when or how
more or less,
does it turn into a medium for waves to propagate through? I've not been able.
Light doesn't turn into a medium for light to propagate through. Light is, if you will, its own medium. It carries its own the electromagnetic wave that can be described as a photon carries itself. It does not need a medium.
I'm able to find an answer to that, and I'm not sure it exists. So you can see the duality this sets up. In other words, light acting like a wave through a medium versus a particle projectile of light, which are not compatible with each other. And then a few months later, in 1905, Einstein released this paper, which is now considered special relativity. In this paper, he talks about the light medium that is required for wave theory, and then he takes it away with this theory. He says the introduction of a light ether, or that is what they called the light medium, will prove unnecessary. So in one paper, he says the wave theory of
yes,
light will probably
it is unnecessary. There is no need for an ether.
never be replaced by another theory. And then a few months
Kind of, yeah.
later, he's changing the wave theory of light by removing the medium for which light propagates.
No, the wave theory of light already was sufficient without an ether. The Michelson-Morley experiment. Whoop, God, sorry, it's bad. It happened in 1887. Einstein wrote that in 1905. That's like, I mean, that's 18 years in between, you know. When Einstein is talking here about
Months later,
the
wave theory of light.
the wave theory of light, they are like, physics has already accepted that there is no ether and that light travels as an electromagnetic wave.
Light will probably never be replaced by another theory. And then a few months later, he's changing the wave theory of light by removing the medium for which light propagates. And he replaces it with his own theory based upon the speed of the photon particle through empty space. And then that leaves the wave theory.
Again, it's not no, they didn't replace it. The wave theory of light was already sufficient without an ether back then, and that's just it.
Of light with a medium of mathematics. We're now waving
No,
mathematical fields.
no, the waves can be expressed as the oscillations of an electric field and a magnetic field.
What the heck is he trying to do here? But that's wave-particle duality. It's confusing. Okay.
None of that was wave-particle duality right now. You just critically fail to understand Einstein's historical remarks about the, if you will, the evolution and emergence of how we came to think of light as they thought at it in 1905.
So, the last thing I want to mention is the 1923 Compton scattering experiment. And it definitely is a very compelling experiment for the idea of a photon particle of light. I don't have anything further to say about Compton scattering because I have not spent time with this experiment yet. But
then why bring it up?
an experiment that anyone can do is the double slit experiment, and this is the absolute best experimental evidence against the existence of photons.
Now that is funny, because usually flat earthers go the other way and say that, no, actually, no, that is what flat earthers usually do.
So here is the basic setup for this experiment. We have a red laser pointer and a diffraction slide. The red laser pointer is a 650 nanometer wavelength.
Okay.
The diffraction slide was purchased from Amazon and is made by 3B Scientific. And here's a close-up of the diffraction slide. So now we can see the wave interference pattern that is created when the coherent light source, or the laser, is shot through this diffraction slide or through the double slit. You have the highest intensity light near the middle, and then you can see the bands of destructive interference.
That is correct.
So these waves interfered with each other and canceled each other out. And then bands of constructive interference.
I mean, that so far is correct. I would like to add here that this doesn't happen here at the wall, but it has already happened at the slit. The waves interact with each other at the slit, not just behind there.
Where the light waves add to themselves. So light being a wave through a medium, which causes an interference pattern, explains this experiment logically. It only gets weird when you add in Einstein's confusion around photon
Einstein wasn't confused. I think you're confused.
Particles, and the illogical concept of wave-particle duality for light. So let's go ahead and play along with the idea of the photon particle applied to this experiment. There are plenty of videos that already go into detail about the double slit experiment, but this Dr. Quantum animation seems to be a very popular one. And you can see right here, if you are shooting the idea of photon particles through the double slit, you would end up with two dots or two bands as shown here. But when you do the experiment in real life, you don't see the two bands of these photon projectile particles. So then how do you explain
Correct.
photons making this interference pattern?
Because the wave function of the photons interact with each other behind the slit, or right at the slit, actually.
It is because the photons are in a quantum state superposition. And while in that state, a single photon can pass through both slits at the same exact time and interfere with itself. This allows
With its own wave function, yes.
us to see the photon particles in an interference pattern like this because it is in a quantum state superposition at this time. So if the photons quantum state superposition were to decohere right now, then it would go back to
bring in decoherence. That's a bit of an advanced topic. So for everyone who's looking who doesn't know what decoherence is, and that is perfectly fine, right? I only learned about it not even in Introduction to Quantum Mechanics, but I completed a course that was supposed to give an insight into how we can test quantum effects on quote unquote larger scales, right? And for this to work, you need to talk a bit about the interpretations of quantum mechanics. And there are so many that I will not go into all of them, but I think the most practical approach here, apart from FAP irreversibility, with double P, you little stinkers, is decoherence. Decoherence is really nice, where it says that due to the interaction with the surrounding waves, a quantum state can only be coherent for so long. So, if you will, decoherence is the process, I guess you could call it, that makes quantum mechanical effects into macroscopic classical outcomes that we know. That is decoherence, because it interacts with all of the wave functions of the surrounding media, right? That is what's going on.
The two blobs that we saw on the Dr. Quantum picture. As you can see, this is some of the quantum weirdness that people talk about. Sure, it's weird, but it's because it's wrong, not because this is how nature.
If it was wrong, then how can we build computers when our basic understanding of how silicon chips work is fundamentally based on quantum mechanics and on the movement of electron through solid states? And I don't know who's texting me all the time. I apologize.
Nature works. So from a particle perspective, you're looking at a fully cohered quantum state superposition of photons. What I'm going to do now is...
No, very much not. Oh god, no. Coherence could not last this far by any stretch of the imagination.
Is add more...
You can only see this pattern, this interference pattern, because from a coherence or decoherence view, right? That immediately after the slit, the wave functions interact with each other, immediately destroying their own coherence and becoming some sort of classical field or some sort of classical outcome right at the slit. Coherence is only maintained in extremely low temperature environments that are usually also vacuum. So nothing here is coherent, from like coherent in the quantum sense.
Noise to this environment to try to decohere this quantum state superposition of photons.
What?
Now, why would I do this? This is why...
I also didn't expect that. No, you cannot do that with a heat gun because it's already decohered. The decoherence happens immediately, almost immediately at the slit, like extremely briefly afterwards. You heating it with a heat gun is not going to do anything whatsoever.
Quantum computing is not working is based upon noise in the environment.
Decoherence, I mean, you could say it's based upon noise, and actually the change in temperature would change how coherence and decoherence behaves. That is correct. But first of all, a heat gun isn't going to add that much heat in relative terms. You know, the air in that room has about 300 Kelvin. The heat gun on average adds a couple of Kelvin there. So, you know, I mean, locally it adds more than that, but still, that's not going to make that big of a difference, first of all. And secondly, again, the decoherence has already happened. It has already gone over into a classical thing. Like there are no quantum waves around anymore. Like, I mean, they are, but there are no superposition states along anymore. Those have long decohered. If you go with the more classical interpretation of quantum mechanics, people would maybe say here the wave has already collapsed and has become a definite state.
Quantum computers are not working because they are having trouble maintaining quantum state superposition. And
that is at least, I won't say correct, but that's not as wrong. They are in fact having problems with decoherence, but not huge ones. Just like it could be better if we solved a couple of these problems, but quantum computers still exist and work, you know.
Their reasoning is because there is external noise in the environment that is decohering the superposition that they're trying to maintain inside these computers.
That was surprisingly close to correct here. That's a bit too simplified for my taste, but that's okay.
So why am I able to maintain this quantum state superposition of photons?
Because it's not decoherent anymore. It's you know, whatever.
Someone that understands the story of quantum physics would probably think I'm an idiot for using a heat gun, because in order to collapse
well spotted
the quantum state superposition, I need to measure the photons, not try to heat them up.
In principle, you have it written right here. You need which way information about not only that, but you need to the issue here is that the decoherence again happens, if you will, directly after the slit or right at the slit in this environment that you're in.
So if you try to measure which slit the photon passed through, then that will collapse the photon's quantum state superposition.
That is the more classical approach, which I find interesting because you've earlier been talking about decoherence. Those are two different schools of thought, if you will. The more classical Copenhagen interpretation is that the wave function collapses at some point, and the interpretation that I like most is that is the one with coherence and decoherence, probably because that's the one that I know most about, and thus I'm most comfortable using it. But in decoherence terms, the decoherence happens right at the slit.
Makes sense because somehow photon particles of light know when they're being measured.
No, they don't. They don't know what they're being measured. This goes into this quantum mysticism that people who have absolutely no idea about quantum mechanics love to bring up. But that's just not what's going on here. What is really happening here is that if the photon, it's too complicated for me to explain like that. I have, however, a video. That's the only thing I have prepared because I saw that they were talking about the double slit experiment,
which produces light.
This is from the University of Vienna, or like at least from Professor Zeilinger, who is at the University of Vienna.
Called photons, one at a time through two tiny slits in a screen.
The laser there is not the thing that they will actually be shooting through. It's just for correct alignment.
With a laser which produces light, this light is attenuated such that only one photon at a time,
a single photon,
emerges. This photon passes through a two-slit assembly, and then we have a camera which registers the pattern behind the two-slit assembly. So what we see is that the photons arrive one by one on the screen, some here, some there, and it looks pretty random.
Since the photons travel one by one, some through this slit, some through that slit, you would expect them to leave a pattern of 2 stripes on the wall. And you would be wrong. They mysteriously create a band of stripes. This is what you would expect to see if a constant beam of light shined through the 2 slits. It would spread across the wall like a wave. So how can single bullet-like particles of light create a wave pattern? This could only happen if the particles go through both slits at the same time.
And I completely agree. So this is wave behavior, but the thing that you can see here on the detector,
only pass that the photons.
The thing that you can see here on the detector are particles. So the way that they lay it out here, I think it's very clear that light can be waves and particles.
One by one on the screen, some here.
So, you know, but with that, I think I am done for this video. I'm unsure if I will make a follow-up video on that thing. There is apparently a part 2, which I don't want to have a look at, to be quite real with you, because this has been surprisingly painful. Anyway, if you enjoyed this video, please consider leaving a like. If you enjoyed it a lot, maybe even considering subscribing. And with that, I will see you in the next video, of whichever type this will be. And yeah, I will see you then. Goodbye.